intelligence and memory and some other cognitive topics. So I just wanted to acknowledge that I stole this picture off the internet. Cute little girl wearing glasses to indicate, oh, that must mean intelligence, right? Stereotyping. So generally, most of us psychologists agree that intelligence is really a composite of abilities, that it's not one single thing that determines whether a person is intelligent or not. Instead, it's the grouping of abilities. Binet talked about this composite of abilities as a general capacity for comprehension and reasoning. Binet was a French test maker back in the early 20th century, and he was hired by the French government to develop a test that would enable the French government to determine which children were ready for school. It wasn't about assessing innate abilities that distinguish one child from another permanently. It was looked at as basically assessing where the children were right now and whether they were ready for school. With the assumption being that if they weren't ready for school right now, that with a little bit of background work and exposure to different kinds of content, they could become ready for school. So the thing to note about Binet was that he thought that that nurture played a really big role in intelligence. So he developed a test that was designed to determine which kids were ready for school and which ones needed a little bit more background work before they came to school. Spearman, on the other hand, developed what is called a two-factor theory, and he did think that intellectual abilities were innate, that it was something that differentiates people, probably was genetic. Now, in his two-factor theory, the one that people tend to remember the most is the G factor, this general intellectual ability that he introduced. And he really argued for tests that would assess G factor. He argued for those tests to be used to help determine who has more of this quality and who has less of it, not to try and figure out who needs remediation or something like that, but really to distinguish between people. But what a lot of people forget about with Spearman is that he actually had a second factor, which he called the S factor. G was referring to general intellectual ability, and S was talking about specialized intellectual abilities. Some people back then called them talents. But specialized intellectual abilities were maybe having great spatial skills or great verbal skills or great math skills. You have these specialized abilities, things that might allow you to do well with music or other kinds of skills like that. So we've got this group of people who sort of looked at intelligence as a composite of abilities. And I've just pulled out Binet and Spearman as good examples so far. We've also, on this slide, got Gardner, who is probably the king of all the composite abilities, the idea that we have multiple independent intelligences. He thought that, two factors was not enough. He thought that the different kinds of intelligences that he labeled were independent of each other, that you could have a lot of one kind of intelligence and a little bit of another kind, and that wasn't contradictory, that you can vary in how much of the different kinds of intelligences you have. So let's talk about his model. So one of the intelligences was what he called verbal or linguistic intelligence, the ability to speak well, to have a broad vocabulary, to understand language, to write language and read language, things like that. So standard verbal abilities. Then we've got the logical mathematical, and this will look really familiar if you're aware of any kinds of intellectual testing, right? We do a lot of logic questions or mathematical questions in those kinds of tests. So far, the two that are here so far look very much like what Spearman would have talked about, Binet would have talked about. And then he starts adding in some that they maybe wouldn't have talked about. Maybe this would have been one of Spearman's special, S factors, musical rhythmic ability. For Gardner, that meant that you could produce music, that you had good rhythm, that you appreciated music, those kinds of things. Bodily kinesthetic referred to having good control over your body, knowing where it is in space. A lot of times when people try to illustrate this component of Gardner's model, they'll show like an athlete or somebody who's dancing, somebody who has really good control over their body. Visuospatial intelligence is, partly the ability to, produce art or appreciate art, but it's also knowing where you are in space relative to like north, south, east, west, those kinds of tasks. Being able to recognize a rotated object in a different orientation, those kinds of things would fall under that. Intrapersonal refers to your ability to get along with yourself, which sounds a little odd, but what he's talking about here is your ability to recognize your own mental states, your own emotions, soothe yourself when you're upset, get yourself boosted up when you need to get, ready to, perform or something like that. So really being able to manage your own emotions and your own mental state. Interpersonal refers to your ability to get along with others. So with interpersonal, are you able to recognize other people's emotions? Are you able to provide support to other people when they need it? Are you able to recognize a person who's angry versus a person who's scared? Things like that. So interpersonal is your ability to get along with other people. So what I've introduced so far, these first 7 were his original intelligences. He's been adding more on as time goes on. So naturalist is one of his more recent add-ons. And this is the person's ability to recognize their position in the ecosystem, their effect on the environment, things like that, to take steps to minimize their impact on the environment, things like that. Existentialist is the last one that he's offered. And this is really realizing why you're here, what your function is, what the purpose of life is, these sort of existential questions that we all struggle with, like in adolescence. He says having a good grasp on what your purpose is and what life is about and stuff like that is a type of intelligence that he called existentialist. Now, if we got a different theorist to analyze Gardner's model, they might argue that he's got so many different kinds of intelligences that he might be moving outside of intelligence and into talents, especially when we talk about like the bodily kinesthetic, the musical, the visuospatial. Certain aspects of the definitions of those intelligences sound a lot like talents. The interpersonal, intrapersonal, a lot of people will argue that that's not really an intelligence as much as it is something that might have been socialized and things like that. So there are arguments about whether Gardner's model is the best explanation. But I can tell you that you're probably familiar with Gardner's model, whether you are aware of it or not, because it's really had a big impact on K through 12 teaching. A lot of lesson plans are oriented towards helping kids with their interpersonal and intrapersonal intelligence. Of course, the verbal, linguistic, and the logical, mathematical, that's always been part of school. But when we talk about, for example, the musical, the bodily kinesthetic, and the visuospatial, this is one of those groups of intelligences that a lot of people think isn't part of school. Like, why are we wasting our time teaching kids art? Or why are we wasting our times on PE? Or let's get rid of music from school. And so a lot of people would argue that you're depriving kids of developing fully if you take those things out of school, right? So, I mean, you can kind of see maybe in your own experience from school that your teacher might have taken advantage of the fact that maybe you have more of one of these intelligences. Like, let's say, for example, you're excellent with bodily kinesthetic and you love sports and you are really into, let's say, baseball. A teacher could use that interest in baseball and that intelligence that you have about baseball to help boost, let's say, verbal linguistic. Maybe all you want to do is play baseball, but maybe we can get you interested in reading by having you read books about baseball. Or we could look at maybe a child who's having difficulty with mathematical issues, and maybe if we converted them into things that they're really passionate about, like stats from baseball, suddenly they'd be interested in the math, right? So a lot of teachers have been trying to take advantage of, naturally occurring components of intelligence and using those to help direct kids towards the parts that maybe they need work with. So, all right. So those are our big models that I wanted to cover. I wanted to kind of transition more into a cognitive theory approach to intelligence by introducing Piaget's concept of intelligence. He really looked at intelligence as a process. It isn't a thing that you have or not. It is instead a way of thinking, a way of approaching the world. And so He looked at it as much more fluid and much more something that grows with experience. Piaget has always, across the whole time we've talked about Piaget, he's been more interested in how a person thinks than what they think or how much they think or something like that. He's really always been interested in their process. So he's a lot less interested in what a person knows. And one of the things that we'll notice about a lot of our tests that we use for intelligence testing is that they'll ask content kinds of questions, like the Wechsler, which is used to test intelligence there's one version for children and another one for adults. The Wechsler test will ask questions like, what day of the year is Independence Day? Which I always thought was a pretty good example of what might be wrong with intelligence test questions, because that's sort of assuming that the only Independence Day that the person might know about is 4th of July. But there are other countries that have won their independence, and then their residents have come to the U.S. now and might be taking a Wechsler test, and they might say, what are you talking about with 4th of July? I'm talking about the one that I know. And I still know what the concept is. I understand the question that you asked me. It's just that I have associated in my mind the what that I know is different from what you're expecting, right? But my thinking, the how I think, is perfectly in alignment with the question. So what Piaget really emphasized is that the environment interacts with the intelligence that the child maybe inherently has. And it's a feedback loop where the child acts on its environment and then learns from the experiences that they have in the environment, right? So, dumping water out of the bathtub causes mommy to take my cup away. That gets ticked away, and the child realizes that there are circumstances where you're allowed to dump the water and circumstances when you're not, right? And it gets kind of stored away in their general intelligence about how the world works and what behaviors will lead to the kinds of outcomes that the child wants. So Piaget really focused on this interplay between the child's innate, if you remember back to when a child was about 1, he characterized children as the little scientist, right? So you have this innate drive to understand the world, and then this feedback from the environment about how well the child understands the world, things like that, that is what builds intelligence and intelligent behavior, at least. So that dynamic interplay is what Piaget really focused on, that it's not just in the child, like Spearman might have said. It's not purely from the environment, like Binet might have said, but instead there's this dynamic interplay. Now, as information processing, when we talk about the information processing model, it's kind of less precise. For one thing, there's not one single psychologist whose name is attached to it and stuff like that. But as a group, people who follow the information processing model say that intelligence is really whatever cognitive strategies the person invokes to solve different kinds of problems. It can be trained, right? If you maybe naturally are not using the most effective or efficient cognitive strategy, we can teach you a better strategy. So that implies that that intelligence isn't purely innate. It can be trained. So I'll give you some examples. So if you have black and brown socks in a drawer and it mixed up in a 4-to-5 ratio, so there are 4 black socks for every 5 brown socks in the drawer, how many socks would you need to pull out to ensure that you get 2 of the same color? Does it matter that they're mixed up in a 4-to-5 ratio? Your goal is to pull out 2 of the same color. Does it matter what the ratio is? It doesn't say how many would you have to pull out to get a black one or how many would you have to pull out to get a brown one. It says how many do you need to pull out to pull 2 of the same color. To illustrate, I'm going to take us back to what Piaget would say are concrete operational thinking and look at the possible combinations if you pull out 3 different socks. Just blindly pull out socks. I couldn't find the exact same sock in both colors. So, so we've got basically 3 will always suffice. 2 of them will have to match if you pull out 3 socks. 2 will have to match. Ratio doesn't matter. So if we can learn to ignore the irrelevant parts of a problem and focus in only on the parts that are important, we will display what appears to be more sophisticated intelligence. right? Whether it was inborn or trained doesn't really matter, does it? As long as we are able to solve problems effectively and efficiently and correctly, right? So I've kind of already started to set up the nature-nurture controversy by talking about Binet as being very much of a nurture guy and Spearman being very much of a nature guy. Let's talk about what we know from research. Research has shown us that about 80% of intelligence is due to genes. So we're starting as a group of psychologists to think that the vast majority of a person's intellect is probably inherent. But does that mean nurture doesn't matter? Definitely not. So follow me along in this little chart. And I've covered up parts of it. I just want you to look at what I'm showing you at the moment, and we'll keep looking at this chart. So here we have a lower correlation among fraternal twins who were reared together on their intelligence scores than we have among identical twins who are reared apart. So if you recall back from earlier in the course, we talked about identical twins share 100% of their genes in common. Fraternal twins share about 50% of their genes in common. And we talked before about how psychologists have studied twins who were separated at birth and then reunited. So we're looking in that column that's labeled identical twins reared apart as identical twins who were separated at birth, raised by different families, and then brought back together in that study that has been examining twins. So we've got identical twins who did not experience the same environment, scoring more similarly. That's what we mean by the correlation between their scores was higher, right? So if I know the IQ score of one of the identical twins, about 72% of the time, I will be correct if I just assume that the other twin has the same score, right? Whereas with the fraternal twins who were reared together and experienced the same environment, I will only be right about 60% of the time if I assume that they have the same score. So clearly, the more genes you have in common, the more similar your scores will be, independent of whether you were reared together or not. Okay, but as I mentioned, don't look at the whole picture yet because I have to make a nurture argument, and I'm going to point at another aspect of this same chart to make my case. So what we like to think about with the nurture side is that, yes, about 80% of our intelligence is due to genes, but there is an effect of environment that can moderate how those genes are expressed. So we call that gene-environment covariance. The two of them sort of work together. One of the things that can happen with our attempts to study the role of environment versus the role of genes with regard to intelligence is that we have muddy data because the parents who produced the offspring and gave them their genes are usually the people who reared them. And so gene and environment is covarying. Those things are moving together. So the twin research is really helpful for us to really suss out the importance of nature versus the importance of nurture. So let's look at this column again, the identical twins reared apart. And notice that they have a lower correlation than the identical twins who are reared together. So being reared together had some impact on those identical twins' intelligence. So now looking at that far column on the left, I'd be about, 87% correct if I assume that the identical twins who are reared together have the exact same score. So something happens thanks to environment. We're not entirely sure what part of environment is the most important, but it's probably not the shared home environment that's the most important. Probably it's non-shared environment, but it's hard to say because the home environment is on average provided by the same people who provided the genes. And so it's very difficult to pull apart the impact of how the parents parented and the genes that the parents provided. But now I want you to look at this chart, sort of step back and just look at the pattern of the green bars. And notice that they're like stair steps, almost the exact same proportion of decrease going from left to right. So the more you share with the other person, genes and environment matching on the far left gives you the most predictability, the highest correlation between scores. You take a little step down if now all we have in common is our genes and we don't share environment. Take another step down if we share our environment, but we only share half of our genes. Take another step down. Here we have siblings who are reared together. Okay, now siblings and fraternal twins share the same amount of genes in common. They both have about 50%. But fraternal twins shared the womb at the same time. They are the same age. They get treated by the environment very similarly, whereas siblings, regular siblings, are treated less similarly. So we see that drop in environmental overlap, and you see this drop in correlation between scores. And then finally, the last one on the right is unrelated individuals who are reared together. So people who are adopted into the same family. And you see that they don't share very much of their, there's not much correlation in their IQ score. So environment probably does something, maybe accounts for 10 to maybe 12% of the variation between people. But genes seem to have the biggest impact on outcomes. All right, our final segment is on memory. So let's talk about some interesting things about memory. Most of us experience what's called childhood amnesia, where we really don't remember much from prior to about age 4. If you think about it and really try and think of a memory that isn't one that you know happened because you've seen the pictures or it's part of the family lore, and so you know it happened, but you don't independently remember it. Try and think of something that you actually independently remember. For most of us, that's going to be somewhere around 4. Now, some of you might have earlier memories. Maybe you recall your younger sibling coming home from the hospital and you were only 2.5 or 3 when that happened. Or maybe something traumatic happened and, a house on fire or the death of someone or an accident or something. You may have memories of that. They might be really imprecise, but you might have memories of some shocking things, something like that. But for most of us, about age 4. In fact, all the way up to about age 9, memories are really hard to recall. Childhood memories are very amorphous, we call them, where there's sort of, maybe you'll have a smell will trigger you to sort of feel like you remember something associated with it and it's not really clear. Or you'll hear a song and that'll remind you of something, but it's not really clear, that kind of thing. Usually the memories that we have prior to age 9 are, again, those things that are very distinctive. And distinctiveness is determined by like being surprised, being scared, those kinds of things. So they're really, don't beat yourself up if you don't remember much of your childhood. I've heard people say, well, isn't that a sign that something bad must have happened? No, it's not. That's how your memory works. We just don't remember very much prior to age 9. So if that's true for most of us, why would that happen? Well, Freud says we repressed it, that there were bad things. He says that prior to age 4, we got born, and that had to have been bad. And then we got weaned, and then we got potty trained, and, all these things that were just so traumatic to us that we just placed it all into unconsciousness and we repressed it and we can't think about it anymore. Probably not. Piaget argued that part of the reason why we don't remember things from when we were little is because we don't think like we used to when we were little. Most memory researchers have determined that children think in pictures a lot more than words. And so their memories are stored in a different format than you want to retrieve them as an adult. And that might help to explain why an odor might bring back like this sort of imprecise feeling more than it brings back an actual, oh, that was when I was at grandma's house or something like that. Information processing, to kind of build on Piaget, say that really it's like you stored the information from childhood in, Word 1.0. I don't even know if that existed. And now you're trying to retrieve it in Word, 11 or whatever we're in, right? That it's just the wrong format. And so we just can't really pull it up because it's unavailable to us. Now, Freud would argue, it's repressed, and so we should be able to pull it back out. And a lot of people really like that idea that, if I was hypnotized or if I went through free association, I'd be able to pull it back out. The research on that kind of attempt to pull back old childhood memories has shown that a lot of times people will produce what sounds like something that could have been a childhood memory, but it's actually them just sort of imposing information. They've done research where they've actually had children adults reproduce while under hypnosis memories from their 5th birthday or other things that they said when they weren't hypnotized that they couldn't remember. So they'd have them produce information, and then they would compare that to what the parents actually had recorded from what happened on their 5th birthday, things like that. And people would produce very confident seeming memories, and they were completely inconsistent with what was recorded as having been true. So probably we don't repress it. It's probably not back in some status that we just need to reveal. It's more likely that we didn't store it in a way that we can retrieve. Now, one of the things that grows with advancing cognition is meta-memory. And meta-memory, the word meta always means awareness of. So meta-memory is our awareness of how our memories work. And kindergartners start to understand how memory works, and that their memory might be faulty, and that they might benefit from external cues and stuff like that. So they do things like they recognize that they need to practice. So they might rehearse over and over and over again the thing that they need to remember. They might tie a string on their finger, hoping that that'll help to cue them. They know that it's harder to remember lots of things than it is to remember a couple of things, right? So for example, you see these children playing this memory game on the right. A child recognizes that a lot of cards that they're trying to match up is going to be way harder than if they only do a subset of those cards. So they're aware of how their memories work. And they do a lot of things to try and cue themselves, to record that they need to do something, ask somebody else to remind them about something. So it shows that they really understand that they're highly likely to forget and that they're going to need some kind of prompting. Now, categorizing as a memory strategy really emerges with age. So there's been a lot of research on kids' memories and how they use categorization using just simple lists. I actually did research on this topic when I was a doctoral candidate, and we use very simple lists. I always used what are called paired associates of words that are related to each other, like king and queen and black and white and salt and pepper and stuff like that. Usually you scramble them up into a mixed list and see if the kids can remember the list of words. What they found is that the youngest kids tend to focus in on the words that rhyme. So they'll remember the sun fun, but they won't remember, black and white necessarily. By age 3, they start to display more syntactical categorization, where they recognize things that go together because they are used together, or that they do that thing. Men goes with work, or I'm trying to think from my own personal list, a good syntactical association. I don't think I had any syntactical ones. I was focusing more, my list was a lot more clustering. So it had like things that went together categorically, like apple, peach, king, queen, a lot of opposites, black, white. Things that go together would be things like salt and pepper, things like that. By about age 5, they start to think, well, I'm supposed to recall it in the list in the order I was provided. And so they won't necessarily generate apple and peach next to each other. Instead, they would just try and recreate the list in the order it was presented, which is like the hardest way to remember a list, when the list contains, categorical contents and things like that, or rhymes or anything. Because now you have each individual item and you have to try and recall it on its own. And so list learning is a really good window into how kids use their memory as they age. After about age 10, they go back to starting to see the relationships among the words that will actually produce the best memory. And so then you start to see, after about age 10, kids displaying sometimes rhyming, if that's what makes sense, syntactical associations, if that's what the list demands, clustering, if that's what the list demands. So you see them being a lot more flexible as they age. The children that I tested were 11 and 12, and I saw them recalling the list of words in exactly the same fashion as college students did. So by the time we get to late childhood, we'll start to see them using memory strategies that are very similar to adults. So I think I already said all those things, right? We start to see the kids starting to use categorization, and it definitely grows with age. So hopefully I clarified some stuff about intelligence and memory and information processing and stuff like that, and you understand the mind of the child a little bit better. All right, I'll see you in the next chapter.